So how did you apply to the SR-71 program, and how did that come about? How did you get into that?
I didn't apply to it.
Okay.
We flew T-38s, and the SR-71 squadron and the U-2 squadron both used the T-38s, and we flew in the 38s together. In other words, it didn't matter whether or not it was a guy from the U-2 squadron flying with the guy from the SR-71 squadron, or two SR-71 guys flying together, or two U-2 guys flying together. So one day we were scheduled for a two-ship. In my airplane was the squadron commander for the SR-71 squadron. I don't remember who the other two guys were. We went flying. We had a good day, and we had a squadron bar between the two squadrons. We're both on the second story of a building. One end of the building was the U-2 unit. The other end of the building was a SR-71 unit. We tended to meet together in the middle. So we met together after the sortie, and this was Al Jors, who was the speed holder for the SR-71 speed record. He says, "Stormy, you fly a good airplane. How'd you like to be an SR-71 pilot?" And I had just worked into being the operations officer of the U-2 squadron. And there was, it's like F-16s and F-15s. There's a loving animosity between the
rivalry.
Two of them.
Yeah.
Yes. And there was rivalry between these two. In some cases, perhaps taken a little too far, as some rivalries can get. In other cases, just pure fun. And so for me to go from the U-2 into the SR-71 was a big deal. Early on, they had about 6 or 8 guys who went from the U-2 program into the beginning of the SR-71 program. But then it didn't happen again that would have been in the 60s. Mm-hmm. It didn't happen again for 15 to 18 years before a couple of the guys went. And I said, it didn't take me long. I just said, I'd like that. And that started the ball rolling. So I didn't really go through the full interview program. They already knew that I didn't get claustrophobic in a pressure suit. Everybody, because we flew 38s together, we hung around together, we did various functions together. It wasn't like, because part of the U-2 and SR-71 interview program is to make sure that the guy that you're about ready to hire will fit with the rest of the people. And he is going to pre-flight your airplane for you, and he has to be dependable. You can't walk around an airplane and pre-flight it for yourself, or even very, very well read the forms and ask questions about what's wrong with, what does this mean in the forms? He has to do it. He checks the weather for you. He does a lot of things that you would normally do on your own. So you have to have a trustworthy guy. And so part of the interview process, although they very seldom say this, is whether or not the rest of the people in the squadron feel like they could trust you to be their wingman, if you will, while you're mobile and for them. That part, I was already a known entity, if you will. I did have to take, now in the SR, what they do for an interview program was they would fly you in the 38 a couple of times, and they would also fly you in the SR-71's simulator. And the simulator was really very good, except for out the window visuals. It was pure IR. It was just a frosted plane. But it was effectively, I think what they were doing was making sure that they would kind of give you a checklist and read to you about the different things and what you were supposed to do. And then you were supposed to be able to go repeat that later and duplicate that. And so, and not make too many mistakes when it came time to, how do you deal with this? And they would give you an emergency. And you wouldn't necessarily know what the things were, but from a pilotage type thing, how do you handle having a firelight come on? Or how do you handle having this on? Just from pure background of knowing airplanes, not necessarily, oh, you have to turn switch A on, then pull tab B and insert tab C. Just what would you do and how do you do this? and then the flight in the 38. Well, they didn't fly me in the 38. They kind of waived that. And the biggest thing for me was taking the simulator flight, which was over several days. They'd show you something one day, and the next day they expected you to be able to regurgitate everything that you'd been taught the first day, and
wow.
the same thing for the third day. So it was interesting and not necessarily a given. I didn't feel like, oh, I'm a shoo-in.
Right.
I felt like I had to work for it there.
Yeah. Well, so did they have a 2-seat version, or was it simulator
Yes.
to the jet?
No. Although you had about 200 hours in the simulator before you got into the airplane for the first time. And our simulated missions were often 4 hours long. They would waive the refueling part because you couldn't do that in the simulator, but they would do a lot of things. And but the 2-seater, there was originally 2 2-seaters built for the SR-71, and one of them crashed fairly early on, and so they only had a single 2-seater, and so it was scheduled very, very tightly. It had certain many hours to fly, and you flew what you were told to fly.
Wow.
You didn't overfly that, because that means that somebody down the line, if everybody flew an extra tenth, somebody
Right.
who was supposed to get a sortie wouldn't get a sortie because 10 guys had taken a tenth
extra,
each.
yeah.
So
Yeah.
it's 1 hour before it has to go into phase or for a special inspection or something like that. Every 5 to 6 years, every U2 and every SR-71 goes into a major overhaul. It goes down to Palmdale and is totally taken apart to everything. I mean, every part is taken apart and then looked at, inspected, and then put back together again with new parts where needed, or patches, or fixes put onto things. So they were very carefully looked at. And so when this airplane, the 2-seater, would go into that particular thing, it really put the kibosh on training. So they had to get it there and out of there in a hurry. And it was not a simple process, but they would, because it was such a critical airframe, I think they worked 24-hour shifts on that when they did that particular one.
Wow. Well, so was the simulator in a pressure suit, the 200 hours? I mean, they just
It could be, not
gear?
all the time. A lot of times I would sit there in a regular flight suit, but there was at least one, if not more, pressure suit things. And I remember one of the ways to indicate that, obviously the thing is not in a chamber. It's not in a pressure chamber. So but you could force the suit to inflate like it would if cabin pressurization failed. And if you took a fire extinguisher and caused that and shot that off, so it filled the cockpit with
smoke,
fog, it was just like having a rapid decompression in it, except so it wasn't quite the same. But they would sometimes do that. And the actual simulator is kind of interesting, because here's the front cockpit, and then melded right behind it, like in a big tunnel, was what would look like in some of the older airplanes, like a flight engineer's station, with knobs and switches and things all over it. And here's where you could play stump the dummy for the guy in the front. You could do all kinds of things to the guy in the front. And then a separate little unit over here was where the same thing was for the backseater. So he sat in the front of this unit with his instructor, his nav instructor, RSO, we call them, Reconnaissance Systems Officer, would sit behind it, and he would do things. And occasionally, certain things happened would influence both of them, and anything that happened to the guy in front drove the guy out of the RSO out of his checklist into yours, because keeping the pointy end going forward was pretty critical. And so oftentimes a malfunction in my cockpit, even though he may be running some malfunction of why this system or sensor is not working or whatever, it would cause him to, I would drag him out of his cockpit and help take care of my problem. There are times when you're all hands and elbows trying to fly the airplane, and you need somebody to read the checklist to you. The airplane got to be a handful at times when certain things happened. And so the cockpit arrangement was such that, like most airplanes, you got a row of flight instrument or engine instruments. So a TAC and an EGT and the normal kind of things, nozzle indicator and a bunch of things like that on one side. Then on the other side of the thing were all the inlet instruments. And there was how the inlet's doing, where the nozzles are, where's the, not the nozzles, but where the spike is, where the doors, because you had several doors that operated in that. Some of them were automatic. One of them was manual. It was kind of like shifting gears in a car that you had to shift that one. And I often thought that if I could sit back far enough and I just kind of defocus my eyes, I could see both of them. Because while you're cruising, if you had a problem with the inlet or the engine, the biggest problem was figuring out, is it an engine problem or is it the inlet that's causing that? And it wasn't always so readily apparent, because a nozzle failure could first show up on the inlet side as a nozzle not quite opening up enough would cause enough back pressure that would travel against the stream of the air flowing around the engine from the inlet to where the nozzle area is, to cause a nozzle to show up, and you'd run an inlet checklist when in reality the problem was the nozzle that was causing the symptom there, or the inlet could cause something that you first notice in the nozzle. You see the nozzle responding weird. You start running an inlet problem when it's the nozzle that's causing you problems. And so sometimes I used to think that if I was a crab and I could have eyes, I could watch them both at the same time, see which one of them moved first. Because once they start moving, now you don't know chicken, egg, and you had to get the right checklist in order to solve the problem.
That's
awesome.
awesome.
So you had to really find out what was causing it. It was not an airplane that you spent a lot of time sightseeing. I have 535 hours in the SR-71.
Jeez.
I would say that I have no more all time 15 minutes looking out the window for pleasure.
Wow.
I mean, and you and I know that in 500 hours, you spend a little time. Oh, look at Lake Tahoe. You know, and you're going to look at it for a little while and you go, oh, yeah, there's stuff around here.
Wow.
No, you didn't spend much time at all looking out of the airplane, because it was like a flying emergency procedure all the time. There were times when it would just fly perfectly normal, but things happen fast, and this is not a very friendly environment. And you don't want to be at Mach 3. And by the way, here's one of the biggest things for your aviation listeners, particularly pilots. I've flown an F4 to Mach 2.2, and I know that our current airplanes, the Raptors, the 16s, these other airplanes can go very fast. And just like my F4 could go very fast. But when you get there, you have a very limited time, mostly due to fuel, that you're going to stay there before you have to go. And the SR-71 cruised at Mach 3. That wasn't, okay, I can go to like saying an F-15 is a Mach 2 or Mach 2.5 airplane. Okay, how many times would you take it there, and how long could you keep it there? Not very often. And the SR-71 cruised at Mach 3. If we're going in the hazardous areas, we cruised at Mach 3.15. That was our number that we went to. And our limit speed was due to a compressor inlet temperature of being 427 degrees centigrade. If you reached that, then you had to back off. On a standard day, 427 and 3.3 Mach equaled. In other words, if you were going 3.3 steady state and it was a standard day temperature outside, then the compressed inlet temperature would get to 427. That was the limit. Now, there have been people who've gone a little faster than that when the days were colder. And a good friend of mine, Dave Peters, who was the chief of stand of Al while I was checking out, said there was one time where it was tremendously colder than standard. And he was flying, and he had to throttle back to min burner. Once you light the burners coming off the tanker, you don't pull them back out of burner until you're ready to descend. The airplane flew in burner the entire time. He was back at the min burner stop, and was raising the nose, and it was just going faster and faster and faster because it was so cold, and he was below 427. So, it's a fantastic airplane. But in standard days, your limit was Mach 3.3. But that was not something that pilots ever went to on a gee whiz thing. Matter of fact, the fastest that I've ever gone is 3.27. That was my speed that I went to. And a lot of the other guys would go to 3.2 something or other. But you were not supposed to go to 3.3 unless you had wing commander approval. Or you had to use, or you were using it to avoid a threat. Our first thing when we thought we were being shot at was to climb and accelerate. And so we would normally cruise at about, if you think about how missiles try to intercept you, particularly the very common SA-2, it's sort of a beam rider. So when it fires at you when you're here, it tends to try to continue to do a curvilinear. It doesn't pick out a point in front of you and fly to that point while you go to it. It's pointing at you the whole time. So it ends up in somewhat of a tail chase. And so remember, it's a rocket that fires, it gets to Mach 3, but then the rocket motor burns out, so it starts decelerating. So you're not decelerating, you're continuing to accelerate. The missile we were most aware of and concerned about would have been the SA-5, which was a really long range, really high speed, still did that same kind of intercept to you, but it wouldn't take them long before they'd figure out, well, we need to start aiming the missile in front of a target to get it. But still, maneuvering an airplane where missiles have very tiny fins and don't have thrust vectoring to help move them around, they're pretty much ballistic, and you don't have to move very much at all to cause a miss. But acceleration is like moving. Acceleration where you're constantly accelerating is like putting G on an airplane. It moves the airplane differently. But we had very few times that we thought we were fired at. I never was fired at, but they would always try to play games with you and see what you would do. We had defensive gear on the airplane. The airplane's huge. I mean, if you ever get a chance to walk around an SR-71 and you stand near the pitot tube and look to the back and you go, my God, that's a long airplane. And then when you see how big the fuselage and how big the engines are, the engines and the fuselage are almost the same diameter. And if right behind the cockpit, the second seat cockpit, all the way to the tail is a little bit taller than what a 55-gallon drum would be, and a little bit wider than a 55-gallon drum if you turn it sideways. And that essentially is a circular tank, and that tank goes all the way to the back of the airplane. It carried 80,000 pounds of fuel internally.
Holy crap. I needed every bit of it, probably.
We used, well, as soon as we got the new digital computers in the airplane to where the fuel efficiency went up because it can control parameters and stuff, well, they found out about it, so they made our missions longer and further so that they could take advantage of it. So we were always coming back to air refueling or coming back to a landing just about at what you would say bingo fuel or minimum fuel. We liked to be able to, now these numbers, because we're talking 80,000 pounds. So what I'd love to do is be able to start refueling when I had 10,000 pounds or less. And you think 10,000 pounds, that's a lot of fuel. In a fighter airplane, having 10,000 pounds of fuel is a lot. But this airplane ate up fuel at low altitude pretty quickly. What would you think the fuel flow would be on takeoff, where you go both of them in burner and you look down and you see the fuel flow?
Oh, 80,000, 100,000 pounds?
82, I've seen 90,000 pounds on one engine.
Yeah. Yeah.
Okay.
God.
So 90,000 pounds per engine, and it varies. It could be 80 to something in the 90s. But when I got up to altitude and I'm cruising and the throttle is back and I'm at Mach 3, and I look down at the fuel flow and I see 7,000. So I'm pulling 14 to 15,000 pounds.
Yeah.
And then what really amazed me was the time I was in one of our tankers deploying back from Kadena, and I was sitting in the jump seat and I was just looking around, and we were at altitude and we're going at, the typical tanker 0.75, point whatever he's cruising at. And I noticed that, he's pulling about 4,000 pounds per engine. Oh, hell. My SR-71 at Mach 3 and the 707 has got about the same fuel flow.
Yeah. What was it difficult to refuel? How was it on the boom?
A big, heavy airplane. So inertia matters. And if you get something moving, then it's hard to get it stopped. So you learn to make fairly small. Now, as far as pitch and roll and yaw, it was pretty maneuverable, pretty responsive. But the biggest thing was learning to not do like they taught us in the T-38 of moving the throttles, kind of walking your hand like this, because that would make the nose go like that as you move. So you had to move both throttles at the same time, because these engines are 15 feet off a center line. They're mid-span on the wing. So there's a 30 some odd foot difference between the two engines. So that meant that if you push one up more than the other, you would turn sideways quickly, so you didn't want to be hunting left and right. The only time it became really tricky is in certain temperature conditions when, like any jet engine, if it's warmer than standard, you're not putting out as much thrust. And as you got to around 70,000 pounds, sometimes you would end up running both engines up against the mill stop. And so now there were several ways that you could handle this, but the one that we most often did was take the left throttle, put it into burner, set men burner, grab the right throttle, and it took somewhere between 3-7 seconds for the burner to light. And when the burner lit, then you'd pull the right throttle back, and now you just use one throttle, and you could use the rudder to keep the airplane going straight, or you could just fly sideways a little bit of crab, which actually helped, because one of the things that I first had to learn about refueling in the SR-71 was that I had to get my seat in the right position to be able to see. My normal position for flying the airplane was up where you just barely look over the nose of the airplane, kind of typical T-38 type scenario. But now the tanker is actually out of sight if I'm sitting there. So I had to run the seat full down, bring the rudder pedals in so I could put my knees kind of go up a little bit, as I'm sitting like that. So I'm now kind of in a kid's chair, with your knees up higher than your waist.
Yeah.
And then put my hand on my knee, but now I can look up and see the tanker and go in and fly it, and then reposition it once I got off at the tanker. But learning to get that particular little nest set up to where you were comfortable with doing it took a little bit. But being in burner on the end of the airplane while you're refueling, if we were really in a hurry, the airplane would take on a lot of fuel. So we could approach the tanker with 10,000 pounds of fuel remaining and refuel between 15 and 20 minutes on the refueling leg and fill up. We always refueled to full. And I would actually take on somewhere around 90,000 pounds of fuel. Now, I only held 80. I started with 10. The difference is what I burned during the refueling.
Yeah.
And so, sitting there now, we had a boom interphone, which was unique at the time. I think other airplanes have them now. When the aircraft and the boom actually connects, not only is there a place for gas to pass, but there's some connections there to where now the interphone system in the SR hooks into the interphone system in the tanker, and I can talk to the tanker. And if I'm in hot mic, I can just talk to the tanker that way.
Mm-hmm.
And during refueling, the backseater would talk to the tanker, to the co-pilot, to tell him how many pumps we wanted. We controlled how many pumps were on because we could take all 4 pumps at first, which was something in the neighborhood of 4,000 to 6,000 gallons per minute into the airplane, which is an enormous amount of fuel coming into an airplane.
That is a lot.
Start doing that. But as we started filling up, we'd start going to 3 pumps, then the 2 pumps, then the 1 pump, because what we wanted to do is kind of like trying to fill up your car at the gas station to where just at the point where you reach the end of AR, you've also reached to where the thing reaches its click off like the fuel tank would, and you're at full tanks, pop off, and then you didn't waste 15 seconds popping off early or 15 seconds longer to get that last bit of fuel, and then just back up a little bit, move to the side, and then go through the hardest part of the airplane from an aerodynamic standpoint was getting it above supersonic or getting it above 1.2. There was a flight test surprise, they call it. They did not recognize at first just how draggy the A-12, the original Blackbird, the single-seater, and the SR-71 was, which are essentially the same airframes. There's differences, but in a gross standpoint, they're the same airplane. How difficult they were to get from 0.99 to 1.15. There's a huge drag curve. And they did a lot of flight test and engineering to fix that, but it still was a hard point. So our standard way to get the airplane supersonic was to pull off the tanker, take both engines to mill, accelerate to 0.9, light the burners, and start a climb from whatever altitude. And if we're over the States, it had to be like this. You had to climb to 33,000 feet, then go full burner and unload, and use a half a G profile going down so as to get to 1.15 before you hit 30,000 feet, because we were prohibited from going below 30,000 feet supersonic because of the boom on the people who would complain for having sonic booms. And then you had to very gently change the airplane from going down to going up, because as you loaded it up, you could bleed off that airspeed in a hurry. It was very, very draggy there. But once you got to 1.15 to 1.2 and you're starting to climb, then you're in full burner, and we'd accelerate to 450 keys or knots equivalent airspeed and maintain 450. Now, for somebody who's an aerodynamicist or an aviator, if I told you I was going to set 450 knots and maintain 450 knots to 60,000 feet, at 60,000 feet, I'm going Mach 2. So as I'm climbing, I'm accelerating, partly because I'm climbing, but partly because I'm not slowing indicated airspeed down. I'm continuing to go. And then finally, at 60,000 feet, I would start to do what we call the keys bleed. I start to let the knots equivalent start to bleed off, so that if I was going to cruise at Mach 3.0, I would tend to pull it back to the cruise power setting at 70,000 feet, and then allow it to climb, cruise climb from 70 to, if you got low enough, light enough, it would be in the low 80,000, 82, 83. If we were going into a hazardous area, then I would level off at Mach 3.15, but that would be at 80,000 feet, where I'd pull it back. And now I would cruise climb at 315, And now it would go above 86, 87,000 feet pretty easily. And on one cold day where I was thinking that I was being shot at, where I had pushed it up, I watched the altitude go up to, wasn't 90, but it was damn close to 90,000 feet, enough to where you go, okay. And then I realized I was no longer anywhere within range of what I thought was shooting at me, and then pulled back. But I was also getting close to what we considered the absolute minimum airspeed, because airplanes stall on airspeed. And so we didn't, I don't care if you're going Mach 3 or you're going 0.2, they stall on airspeed. And so I was getting real close to that 310 minimum limit of airspeed at that altitude.
10.
And
Cool.
310 indicated, yeah.
Yeah. Wow.
Normally our indications at Mach 3 to Mach 3.5 in the 70 to 80,000 feet was about 365 to 400 knots.
Is the guy in the back always a WISO or a RSO, or was it a pilot sometimes? Were there any controls back there, or is it just a sensor operator?
No controls. No controls. He had a little peanut attitude indicator and 3 flight instruments. He had altitude, airspeed, and Mach number, and that's all. No stick, no throttle, no anything. He had the ability to see through a drift sight down through the bottom of the airplane, outside the airplane, and 2 little windows high up over here. No forward visibility except for this drift sight at all.
Wow. When you said you were accelerating, were you talking to center and doing it over center's airspace, or did you have to do it like within the AR route or the MOA, and then once you were above the Class A airspace, you could accelerate? Because you're in the 30s, you're in Class A airspace if you're doing this, right? I mean, how was center
right? And
working with you guys?
We had places pre-coordinated that, a little climb profile that we were going to do. There were times when we just did a VFR climb out over the ocean. We're coming out of Okinawa, and I was going up to the Kamchatka Peninsula to pick up some information. You know where that's at? That's up across from Alaska. And I'm climbing up to the east side of Japan. And, there's a lot of airliners that fly routes. They come, and I had just declared, I was just VFR and avoiding them as I flew up without squawking, just dodging airplanes as I'm climbing up through all of their space, because we're in quote unquote uncontrolled airspace, maybe but most of the time in the States, the centers, we're talking to center. Yeah. And what's interesting about the SR-71 and radio calls and centers is that normally when you're flying across the United States, okay, this is Houston, got you loud and clear, and a few minutes later they'll say you contact Houston now, and give you a frequency, and a little bit later contact. They would have a single frequency per traffic control center.
So Houston's probably looking at some people over Louisiana, and then looking over some people over Houston, Galveston area, and then looking at some people over getting close to San Antonio. And there's a guy looking at a scope that's looking at 200 miles plus or minus of maybe of Orange, Texas, and the next guy's looking at this and so on. What they would do is internally pass us along, so we didn't have to change frequencies, because we would constantly be out of range with them because we couldn't keep up with the frequency. So they had a single frequency for us per center. So if I'm with Houston, I've got one number that I talk to from the time I enter Houston's airspace till I get it, and they internally move us from controller to controller as we go through 3 or 4 different Houston controllers, individual airspaces. Then when I go to the next thing, like I was turning up and going to Kansas City, then at Kansas City would check in, and as I'm flying through there, it would be just one. So it didn't have to make a lot of radio frequency changes, but as fast as we were going, they were almost as fast changing as you do when you're flying in the smaller regions of.
Was this UHF only? Did y'all have a VHF radio?
We were talking UHF. I had a VHF, but we didn't. frequencies that we used in the SR-71 at high altitude were UHF.
Back to flying the thing. I mean, what is it? Land like a T-38? I mean, I figure it
It's
doesn't
a
have
little
much of a wing.
heavier, so you fly a little bit faster. A lot of times,
Like, what's the approach
probably
speed?
like a T-38 heavyweight. If you were to take a T-38 and try and land a heavyweight or single engine heavyweight T-38, it's similar to that.
Like 170 knots or so?
Yeah, 175 on final and 155 for touchdown.
Wow. Yeah.
Yeah. The big delta wing really gave you a nice cushion. If you normally had just pure plus or minus 30-degree headwind, just nice. It was a super easy airplane to land. I mean, you just came in, that delta wing just cushioned into the ground effect and made a fairly nice landing. Then you just aero brake just a little bit, start the nose down, reach up, grab the drag chute, because you're supposed to have the nose wheel on the ground by the time the drag chute was totally out. But you could time it such that, it took a few seconds for it to come out, a few more seconds for it to pop. And you could, do that to try and get it out. From a standpoint of where you were on downwind when we pitched out, you're like where a heavyweight T-38 would be. If you came in and
So you flew initial with this thing.
Yeah.
You came up initial. Wow. Yeah. That's awesome.
Well, if it was instrument conditions, you'd fly an instrument approach.
Yeah.
But if we folded closed patterns. Delta airplanes have a big problem about when they stall, they tend to pitch up. If you take a delta wing airplane to stall. So in order to prevent that, it had a stick shaker as you got close to it. And then if you ignored the stick shaker, it had a 40-pound thrust on the stick pushing the nose down, which would, if you were just grabbing the stick, if you were a real, if you weren't a white knuckle pilot and you were just grabbing the airplane nice and easy and you pulled to that, and it would pull the stick out of your hand. I mean, it would literally, if you're just flying with an easy grip, it was 40 pounds that came pow and moved the stick about 6 to 10 inches forward. But if you were trying to do a good closed pattern to where you were right on the stick shaker and occasionally pop that, you just hold tight against it to go around. But you didn't want to go past that because there was a reason that you had that there. Hey, if you go past this point, you're going to pitch up, and nobody wanted to pitch up and have one end up pointy end nose down in the Beale swimming pool.
Did you ever do any AHC with it, advanced handling, like aileron roll or anything, or was it all straight and level?
It was other than the pitch angles that you would get climbing and bank angle that you would get to in a traffic pattern. As far as I know, no one did. There was one time my Finney flight. I was the Farnborough Air Show pilot for the SR-71, and the departure coming out of Farnborough to take it back to Mildenhall. I toyed with the idea in my head for just a little bit about raising the nose up when I was finished, raising the nose up, just going to 1G and doing a roll. And I couldn't do it because it just, what if you lost the airplane? What if something, nobody had ever done it. And, we treated that airplane like a national asset. We didn't want to, we would sometimes abort airplanes for seemingly minor things, but seemingly minor things at Mach 3 and 80,000 feet are just really weird. And there were a couple of times there, but for the grace of God, go I. I'll tell you one interesting story because it's such an odd thing. I'm on a check ride, and so we're in the two-seater. I'm in the front seat, the instructor pilot, evaluator's in the back seat. And so we go through the normal mission planning, go out to the airplane, crank it up, take off, en route to the tanker, planning on refueling, and then you had to go high and fast, come back around, and then we were going to do a single engine approach and the typical things that you do on a check ride. Well, as I'm I'm on the tanker, contact, taking fuel, and all of a sudden I see out of the corner of my eye something go by my right side. And then the boomer says, "Sir, I think you got a problem." So, okay, disconnect. So disconnect, back off. And what had happened, and this is so odd, what are the extreme chances that this would happen? The tanker has a light, a landing light that's embedded in the leading edge flap that's in his leading edge wing. And they had just replaced that light. And somebody had not tightened it up properly to where the light fell out of its receptacle. And so that's, fallen object report. If that had happened, he goes flying, comes back, oh well. But how many times do you get FOD from something that falls off one airplane and goes into the engine of another airplane? The spike that comes out the leading edge of that was what it hit, but it hit it at the 4 o'clock position. In other words, I can't see it. The periscope, the rear view mirrors that I have, I can only see the inboard side from 12 o'clock, 9 o'clock to 6, not quite 6, maybe 7 o'clock. I can see on both sides, but I can't see 1, 2, 3, 4, 5. And it hit, and the spike is made out of a composite. Have you ever seen a Corvette get into a wreck to where it's damaged the panel of a Corvette to where it just kind of shatters and you get pieces of stuff? That's what that looked like. Because what we did was, okay, check ride's over, go on, because obviously we got a hole in the airplane. What would have happened if we had not known that, or this was at nighttime, the boomer hadn't seen it? Because neither he nor I, other than this little something went by the side of me, but nothing went boom, nothing went bump in the night. There was no indications. But what if we tried to go to high and fast? When would that have torn apart? What would it have done as that whole thing blossomed out like a
Mach 3? Jesus. Yeah.
So we landed, did a single engine approach. We didn't know what was really wrong, so that engine just went to idle. The other one went to whatever you needed, and we landed. And oh man, the whole squad from the entire base came out going, look at this. And so that was just weird.
Well, how did it fly single engine? You said it's off
single
center
engine
line, so
it was wonderful as long as you didn't have to do a single engine go around. Because what you do is you'd fly a little bit faster, and about a half mile on final, you pulled a good engine idle, and you just glide it all the way in, because now you just dissipated that airspeed. There was no asymmetrical thrust whatsoever when the one engine all the way back, and you just come in and land it. Now, the big thing is to do a single engine go around, because if you did a single engine go around, not only did you have to put full rudder in to counter it, but you also had to bank into the good engine somewhere between 15 and 25 degrees of bank. Keep it from wandering off, the nose being pushed off because of this thrust. An enormous amount of thrust, plus, windmilling drag on a bad engine, pull it off even further. The SR-71 has another unique thing, talking about single engines. It's the only airplane I know that has 2 hydraulic systems to retract the gear, but only 1 hydraulic system to extend it. Why would you have that, you think? Well, if you take an airplane off, and let's say we would rotate at 210, fly off at 230, and right then, if you would have an engine failure, duct goes through the intake and just destroys one of the engines. If you didn't retract the gear immediately, you'd lose the airplane, because the nose gear being so far forward, as soon as you started to turn and yaw, now that nose gear is acting like an unwanted canard to pull the nose even further over. So they learned early on that if you had a single engine and you were going to continue to take off, that one of the very first things, besides going full burner, if you hadn't already gone full burner on the bad engine, was to retract the gear. And it had both the hydraulic systems to raise the gear,
Make
But
sure it
if
happens.
but
Yeah.
but later on, it wasn't there to put the gear down. You had, one side would put the gear down. If it was failed, then you put the gear handle down, nothing happens. Then you pull the handle and it would just unlock everything and it would free fall like most airplanes, like a T-38, free falls to the down position.
You
So
were
that's
flying. Yeah, that's awesome. You were flying the T-38 the whole time you're flying the SR-71, right?
yes. Yeah, that's our companion trainer.
So did the SR-71 have any continuation training CT flights, or was it all T-38 if you weren't doing a mission or a check ride?
In the States, we would fly two sorties a month in the SR. Sometimes if you were new, they would give you a little bit more than that. If you were an old head, if you had 300 hours or more, you probably just got the minimum it needed, and that was it. The rest of the flying you got was in the T-38.
You were a major at this time?
Yeah.
Yeah. So you did that for 4 years, and was that all that it was ever intended, or did you decide to go back to the U-2?
Well, what happened was I was flying the U-2 for 4 years. Other than the period of training for the SR, which was about 6 or 8 months, flying the SR for 3 or 4 more years of actual flying. These were really high TDY organizations. So somewhere between a minimum of 180 to 270 days a year, I was TDY in the U-2, same thing in the SR-71. So for 8 years, I had been on this TDY cycle, and I said, I think I'd really rather have a PCS assignment. And what came up was, well, if the U-2 people will have me back, the Alconbury TR-1 unit had just started, and it was a PCS slot, flying U-2s, flying op sorties, but from the UK over Europe for 3 years. So that sounded like a neat deal. So I volunteered to go into that, and had to go on my last SR-71 deployment to Mildenhall. I went down to Alconbury and interviewed with the ops group commander, the 06 in charge of operations. I don't know what they call them today. There's a
the group ops group commander, the OG.
Yeah, OG, and just talked to him a little bit to make sure that he was willing to accept me, and he was. So then I flew my last sortie in the SR-71 like I mentioned before, as at Farnborough, from Farnborough to Mildenhall. And 6 weeks later, I showed up at Alconbury as a fully checked out TR-1 driver, because it didn't take me long to transition from one to the other with all the time I had in the U-2. I mean, it was less than a month of actual training.
Wow.